Hey y'all, it's been a little bit of a while since I've made a video. I've been pretty hard at work at Selectrix and Matrix, but I thought I would show you some of the things that I've learned recently. I owe a lot of debt to an article that was recently posted by the Erlang team. Helped clear me up on some of these issues that it turned out that I was getting extremely wrong, and I'm glad that that timely article dropped. I'll put a link to it in the links below. All right, so the objective of this little session is to kind of get some information on the fly as a module is being compiled. And so, you know, the kind of key step that we want is to get it right after Elixir has done all of its processing and has assembled the Erlang code and just before it's ready to like put its stamp on it and say, hey, this is the module. Okay, so let's spin up this IXS mix, and then I'm gonna clear the screen to make it a little bit cleaner. And you know, we have this module playground, but there's no functions in it. We can't really do anything, right? Okay, that's fine. So let's see if we can do something about learning what's going on when it's on the fly, about to be just finished compiling. So the way you do that is with an attribute called after compile. Now VS Code is going to yell at me. After compile takes a module helper, or it could be any module, but we'll call our module helper, and you can see it yelling at me. It says helper.dunder after compile with an arity of 2 is undefined. So let's go ahead and define that. And this has to be a function, not a macro. And it takes 2 parameters. So we'll call that argument 1 and argument 2. And then, you know, let's say we don't know what they are. So what we should do is we should probably just, you know, drop in a couple of inspects and see what's going on. So let's recompile. And so what you'll notice is that the first value is a macro.env. So what a macro.env is a struct that the Elixir compiler uses to keep track of what's going on. You know, where am I in the code? What are sort of the current aliases that are going on? Am I inside of a function? Am I inside of a match? All those sorts of things that are important for it to have contextual information about where it is in the parser and or compilation. So this carries along with it a lot of sort of local information about, you know, what happened when I compiled the module. It's about to get thrown away because, you know, we're done compiling the module. But, you know, we can get some important things like where the file is, what line. So here it says line 8, which means that the module began on line 8. Okay, so let's go ahead and just pull one thing out, which is the name of the module. And I'm just going to broadcast that to the console, io.puts compiling inspect module. Okay, so we can recompile this. And that leaves, so you can see now it says compiling playground, so we know which module we're compiling. If we had multiple modules with after compile callbacks, this would be able to give us a sense of where we are inside the function, when we're inside the function. All right, A2 is this binary chunk. And what is this binary chunk? This is the compiled module as it would be if it were turned into a .beam file. So as you know, your Erlang VM will load up .beam files. So if you do a deploy and you ship your VM and you also ship a bunch of your modules are stored in these .beam files. So what can we do with that? I mean, I would love to be able to inspect that. Before I move on, I will make one disclaimer that the beam file binary format is not the actual format of the binary that exists inside of the VM when it's loaded. That's a different format. And so this technique may not necessarily work in all cases. If you're in a situation where, you know, you're trying to understand something about a module that only exists in memory and nowhere in disk, you might be in trouble. But those situations are kind of few and far between. And in any case, after compile gets handed this pre-beam file. So no matter what, we should be able to get this information. OK, so let's call this the file binary. And Erlang ships with this module called beam disasm, which will disassemble these beam files. Kind of great. It's just in there. And the key function is this file function. And then so we'll just pass the file binary to that, and then we'll inspect it. OK, so let's recompile. And here's what we get. So we get kind of a complicated tuple. It's got this beam file, which kind of indicates that it's successful. It could be like an error instead. We get the name of the module that's being compiled. This is a list of exports, which means all of the functions that happen to be exported. So that's a def function in Elixir. I'll get into this a little bit in a second. A version hash and some other metadata. I believe this is also some further metadata. And then a list of functions and the bodies of the functions, if you will. And we'll get back into that. But first, OK, so there are 3 exports: info, module info, and module info. I never specify that in the body of my function. Well, those really exist. They're put in by default, whether or not you ask for them. This is a real function. And you can call dunder info is put in by Elixir. Module info is put in by Erlang. So all Erlang modules have this thing in it, and all Elixir modules have this dunder info in it. And note the contents here are the same. So this attributes version is the same as calling playground dunder info attributes. And also that is the metadata that kind of exists up here. So it's nice and consistent. So this is kind of how you would access this information in the case that you can't fully disassemble the binary. OK. So you can see that the compiled machine code for each of these functions is also presented here. So these are kind of rather complicated functions, and maybe it might be worthwhile to look at a simpler function. So let's define a function add, and it's going to take 2 variables a and b, and then we're going to do a plus b. Great. So we compile. And let's look for it. So no. Oh, here it is. OK, function add. It's arity 2, and it jumps into label 8. So that's what that 8 means. So skip this stuff. I won't get into that in this video. But we start at label 8. And when we say we have a toArity function, that means that we drop it into 2 registers, register 0 and register 1. And in the case of add, since we passed it a and b, the value for a goes into register 0, and the value for b goes into register 1. The next opcode is something called gcbiff. I'm actually not fully sure what gc means, but I think it says maybe you can do a garbage collection on one of the values afterwards. But biff means built-in function, and so that means we're going to do the built-in plus function. I'm not going to go into what this is, but it's basically where do you jump to if you get a failure. And it says the plus function takes 2 values, arity 2, and it will take whatever's in register 0 and whatever's in register 1. Now, if you remember, we dropped a and b into register 0 and 1, and it says put the answer into a register 0. The last thing that happens as a result of the add function is a return statement. And what return means is jump out of the function and return whatever was in register 0. And that's great because we put the answer here into register 0. Cool. What happens if we make this function a little bit more complicated? So let's do add and times 2. We're going to make a value c equals a times plus b, and then we're going to return c times 2. OK, let's recompile. And now the function name has been changed to add in times 2. It's still an arity2 function, and I guess we wound up still going to label 8. That's fine. And as before, we do the gcbif add function, and it will take register 0 and register 1 and store it into register 0. The next thing it does is a gcbif multiply function, right? And it will take whatever's in register 0 and multiply it times the literal integer 2, which we specified over here, and then store it into, again, the 0 register, which gets clobbered, and then it returns the result. So that's how it works. There are a whole ton of different opcodes. You can do remote calls, you can do local calls. There's special directives for if statements where you have branching conditionals. There's a way to do selective receive on your message queue. But I think this kind of gives you an overview of the ideas that what exactly happens to the code that you generate in your Elixir modules and your functions, and how that gets turned into an operational set of instructions for the Erlang virtual machine to use to perform the tasks that you tell it to do.